Okay. First, I would like to say a few words about Gérard Brachet, who is the person who has organized this plenary event on space system to observe and understand climate change. Gérard Brachet is the Vice President of IAF and Chairman of a committee under IAF. But some of you may know that he had a severe mountain accident this summer, and he could not come to Daejeon, unfortunately. He is safe, but of course he could not travel. And I would like to devote some thought to him now, and I will convey our best wishes for his prompt recovery, with your permission. As Gérard has prepared this session, he has put 4 major issues to our attention. The first issue is observations of climate change, which are the key observations that require space-based observation. The second is about understanding, which are the key parameters that we do not observe sufficiently well today. The third is about modeling and forecasting, which are the observable parameters required by models. And finally, the last question is about mitigating the consequences of climate change and what is the role of space observation in that respect. To discuss this, we should have a panel of 4 people plus myself. In the end of the session, Ambassador Ciro Arevalo Yepes, Chairman of UN COPUOS, should review the conclusion of the UN IAF workshop that was held in Daejeon on the same topics on October 9-10 last week. And the 4 issues that I mentioned before will be addressed by the following distinguished speakers. The first to speak will be Dr. Takashi Hamazaki, Director of Program Management and Integration Department in JAXA in Japan, and he was the former manager for the Ibuki GOSAT satellite. He will give us a few recent results. We should have the director of the Korea Meteorological Satellite Center, Ms. Asuk Soo. She's at the moment traveling from Seoul to Daejeon, and she should be there within 10 or 15 minutes. I hope so. And then to conclude our discussion, Dr. Gassem Asrar, the director of the World Climate Research Program, will give us a presentation. To start this discussion, I would like to give you a few ideas to review the various 4 questions that were submitted to our attention by Gérard Brachet. The first question is about observation. Do we know what needs to be observed and how? Here I would like to refer simply to the statement by the IPCC, the Intergovernmental Panel on Climate Change, in the 4th assessment report. Warming of the climate system is unequivocal, as is now evident from observations of increase in global average air and ocean temperatures, widespread melting of snow and ice, and rising global average sea level. These are 3 important parameters that need to be observed and monitored, and one can see here that many observations that are used, particularly in the most recent period here, come from space-based observation. So the question about do we know what needs to be observed and how, the answer is yes. The requirements have been carefully stated by GCOS, the Global Climate Observing System. There was a report published in 2004 and a supplement specially devoted to satellite observations that was published in 2006, which state extremely clearly what are the requirements for systematic observation from satellite-based products for climate. And the space agencies are well aware of the GCOS requirements because they have responded to these requirements at the same time in September 2006 with a document which lists a number of actions, 59 actions, which should go very far in meeting these requirements. So do we miss something? If we look at a diagram like this one, which shows the space component of the World Weather Watch in 2006, and you see a number of satellites in geostationary orbit, in polar orbit, plus a number of research satellites which contribute also to the World Weather Watch, the global observing system, one could think, well, we have plenty of satellites, plenty of observation. Do we need more? Trying to resolve this issue was done by CEOS when they made this report, the response to the GCOS requirements, in mid-2006. They look at what is called the essential climate variables, and the status for atmosphere was represented here with top lights on these bar charts. And you can see that in the recent year, the color was yellow, sometimes green, not too frequently, but frequently red for precipitation, for example. We don't have measurements at all. We don't have measurements for greenhouse gases. We don't have measurement for upper atmosphere winds, for example. The same analysis was made for the terrestrial essential climate variables, and you see it's more in the yellow than in the green again, with even a number of important variables like land cover change, which are not really well documented. And the same was done also for the ocean. And you can see that there are several areas where the situation has been extremely bright in the period between 2000 and 2004, 2005, and then it degrades, or it would degrade if decisions were not taken appropriately. And those bar charts were so disastrous that they were not published in the end, but I have them. And so there is something that we need, which is not simply adding to what we have. It's we miss continuity, we miss sustained observing system. Compared to 2006, the situation in 2009 has improved thanks to some decision taken by the European Space Agency, the Sentinel program, and it could improve also with regard to the sea level, for example, depending on the decisions that should be taken by the end of this year, but the decision is not yet taken. The second question was about the major uncertainties in climate change understanding. For example, I list a number of uncertainties here, clouds and aerosols. We have a system in place at the moment, the E-Train constellation, which looks at clouds and aerosols, but this is a one-shot system. We don't know exactly about polar ice balance. The European Space Agency will launch the GOSAT 2 satellite early in 2010, and hopefully we'll know better about that. We don't know enough about the natural variability in the ocean and how we can interpret the variability with respect to trends. And of course, the JSON series of satellites plus the GOSAT European satellite will help resolve this, but we need very long measurements because the ocean is varying very slowly. We don't know much about the greenhouse gases sources and sinks. Hopefully, we know more, and we'll know more in the presentation by Dr. Hamasaki a little later. Unfortunately, the OCO satellite had a launch failure, and there are more uncertainties. So there is still a lot to do, and possibly other speakers will discuss these issues. Concerning the model and space-based observation, what do we need to improve our forecasting of the future? Regarding long-term forecasting for a century, we don't need that much the observation. But concerning what is more important for our society, which is decadal prediction, then we need observation. This is necessary for the initialization of the model, for ocean, for sea ice, for the land processes, and this is also necessary to verify the results and to assess the skill of the models. In both cases, we absolutely require observation. And concerning the impact, the consequence mitigation, we now have many space observations of climate change impacts, for example, sea level rise, which is increasing, and the increase in sea level is accelerating, as is shown by the records from altimetry satellites. We have information since 30 years about the northern hemisphere Arctic sea ice decline also, which has declined by 7 million square kilometers in 30 years. And this is seen as bad news by some and the good news by others, because they can now use easier some routes through the Arctic region. But so we have the warnings, but do we take these warnings seriously enough? And we may continue to see new IPCC report released every five years. But what the reality tells us is that the actual emissions have grown in the recent year more rapidly than the worst, the most pessimistic scenario of the IPCC. So I think we have to think all those questions through, and now I would stop there and ask the next speaker, Dr. Amazaki, to take the floor. Thank you.
Good morning, ladies and gentlemen. My name is Takashi Hamazaki. Today, I'd like to concentrate on two topics. First one is I'd like to introduce our challenge to observe greenhouse gases from space. And the second topic is to compare to talk about the difference between ground-based greenhouse gas observations and space-based observations. I'd like to put emphasis on the merit of space-based observation. Okay, first, I'd like to introduce the GOSAT. GOSAT stands for Greenhouse Gas Observing Satellite. Just before the launch, a new nickname Ibuki was attached. Ibuki means breezes in Japanese. The GOSAT is the first dedicated satellite to monitor global distribution of greenhouse gases from space. GOSAT is able to observe the density of carbon dioxide and methane at the between 100 to 1,000 kilometers spatial scale, and the target accuracy is around between 1 to 4 ppm for CO2 and 0.6 to 2% for methane. This is a joint endeavor among JAXA and the National Institute for Environmental Studies of Japan and the Ministry of Environment. GOSAT was successfully launched by Japanese H2A launch vehicle in January 23rd. And now it's free operational. Okay. This picture shows the overview of GOSAT itself and the scene of launch. Next page shows the current distribution of ground observation points of greenhouse gases. Currently, around 280 ground-based observation stations are distributed worldwide. But unfortunately, the number is not sufficient, and also the distribution is very much biased. We have a lot of stations in Europe or North America and Japan, but we don't have enough stations in Siberia, Africa, or South America. And also, we don't have enough stations over ocean. So global warming scientists are using this data to evaluate their own global climate model. Many regions remain unobserved. That is one of the key points. And after GOSAT, we can drastically increase the number of observation points. So after GOSAT, let me show you the observation points of GOSAT. Comparison is clear. So we have around 25,000 observation points, and the repeat cycle is 3 days. So if the sky is clear, we can get greenhouse gas density data every 3 days. So the frequent observation and global observation can be achieved. And also, we have only one single instrument, so we can provide one common measure to observe the distribution of greenhouse gases. So the number is increased almost 200 times compared with the current observation, and no unobserved area will be remained. And also, current observation station is not sparsely distributed. So the observation is between 1 dimension and 2-dimensional. So I call it a current status is around 1.5 dimensional observation is the current status. After GOSAT, we'll fully cover the 2-dimensional observation. And in addition to this observation, we'll give you some altitude information. Altitude profile will be provided using thermal infrared channel of GOSAT. So the observation will be between 2-dimensional and 3-dimensional. So I'm saying that we'll change the world from 1.5 dimensional observation to 2.5 dimensional observation. And we provide the columnar density, means the average density or total amount of greenhouse gases will be observed. And this picture shows the outline of GOSAT. GOSAT has 2 sensors on board. Tanso FTS, Fourier transform spectrometer, is the primary sensor to observe greenhouse gases. And we have additional auxiliary sensor named Tanso CAI, cloud and aerosol imagers. The reason why we put this auxiliary sensor is that the existence of cloud and aerosol will be major aerosols to observe the greenhouse gases. So we need to monitor the density and distribution of cloud and aerosol simultaneously with the greenhouse gas observations. Okay, GOSAT data will be distributed directly from NIST and JAXA or via existing data distribution network. And also we have some framework with the European Space Agency, and the European Space Agency will provide the data to European scientists. It is under plan. And we are going to start the data distribution of spectra, level 1, at the end of this month. And also we are planning to start the distribution of density data, carbon dioxide density and methane density data, at the end of January. Scientific data use will be in free of charge via internet download. And if the scientists are free to use our data, and I hope many people to use this data to evaluate our data. And this shows the recent results taken from the GOSAT. And the GOSAT is under calibration and validation phase. We have already finished the first stage of calibration and validation, but still we need to work a lot to validate the data. So in this case, only good data is picked up and compared with the ground observation data. White area, the data from white area is not used. So this data is the initial use data between April 20th and 28th. And some red area is the carbon dioxide density of red area is relatively high. But still, we need a lot of study to if this number is correct or not. For example, over Sahara, in some portion, the carbon dioxide density is evaluated higher, but it is not acceptable to us. For example, some sandstorm might have some effect to overestimate the carbon dioxide. For example, the light path is multiply reflected through the sandstorm. That kind of effect might be carefully evaluated in the future. So this is just the first results. And after that, after that, data is increased. And over the ocean, we have sunglint observation and getting a data. And gradually, the number of observation points, the data process is proceeded, and we are focusing on getting the global distribution data as soon as possible. And similarly, data of methane distribution is also processed. And for these applications, we might have a possibility to detect the leakage of the methane gas from the pipelines. That is one of the good applications. And if we get a methane leakage from the pipeline, and we can report it to the pipeline owners, and it will have an opportunity to get the immediate shutdown of the immediate repair will be conducted. In that case, GOSAT will contribute to the direct reduction of emissions. So that's kind of the application is also under conducted. So this shows the graph from the IPCC report, and at the bottom line, a total net anthropogenic greenhouse gas effect is shown. So the 60% of this effect comes from carbon dioxide, and the 20% comes from methane. So it means the GOSAT covers 80% of greenhouse gas effect. But still, it's not enough. We need to understand the distribution of nitrogen oxide and halocarbons. And also, we have a lot of uncertainty remains for aerosol. So in future, we need more observation for aerosol to understand the total greenhouse gas effect exactly. That's all I have today. Thank you very much.
So the next speaker, Mrs. Su.
Good morning. My name is Suksa. I'm from Korea Meteorological Satellite Center in KMA. I am brief my opinion about the issue given by the organizer. Climate change adoption and mitigation is keyword of 21st century for sustainability of next generation and biodiversity. To adapt to mitigate climate change, the global observation data is highly required in that sense. Space-based Earth observation become very important. So, from many countries, many space programs are planned, including Korea. And now, how to utilize the Earth observation data and how to share those information. It is not mentioned about goals or not RSSCCM program, which are led by WMO, because the expert from WMO is here. Climate change caused unusual weather, natural disaster, and water food security, and then leads to poverty and health safe problem. Then what are the key observations, the required space-based observation? I think that the meteorology, that is very basic property observed from space, but that's very important. To understand the climate change, we should understand the daily meteorology. The history of meteorology observation from space is almost 40 years, but the database of long-term global meteorological observation is not adapted yet. We should integrate the global meteorological data not only from stationary satellite, but also polar orbiting satellite. Because of the restriction of geostationary data, as you all know, that those data will be utilized the climate model validation and improve the accuracy of the model. This figure shows the COMS satellite. COMS program will be contribute global observation data building. I would like to introduce the Korea, the first meteorological satellite. We call COMS. COMS means communication, ocean, and meteorological satellite. It is multi-purpose satellite. COMS is now ready to launch, and it will be placed in 128.2 equator. This figure shows that KMA means Korea Meteorological Administration, has been developed the COMS meteorological data processing system, that is CMDPS. There are 16 baseline products of the CMDPS for meteorology, weather forecasting, and climate change research. One of the advanced figure of CMDPS is the CMDPS has its own validation system. With this, KMA can update the algorithm from the validation result to provide with a more accurate product to user. COMS has 4 ground stations. The one is KARI. KARI means Korean Aerospace Research Institute. Has the charge of the satellite monitoring and control, and also it has the load of backup MI. MI means meteorological imager, data processing and dissemination system operation. The second is KORDI, KORDI, Korea Ocean Research and Development Institute, shall receive and process GOSAT data. GOSAT data. The third is E3, Electronic and Telecommunication Research Institute, shall operate the Ka band payload. The NMSC is our National Meteorological Satellite Center in KMA, has the charge of the MI data processing and MI GOSAT data dissemination through the COMS satellite, and also has the load of backup COMS monitor and control system operation. This figure is the COMS data distribution. KMA is trying to contribute to the global climate change mitigation and adaptation by supporting the ground processing system of COMS satellite and other meteorological satellite data, and IT infra to utilize the COMS data in the field of weather and environment to East Asia countries, which are directly suffering damage caused by climate change. Okay. This figure about the key parameter in terms of climate dynamics that we do not observe sufficiently well today. I think that is the precipitation. Temperature change are one of the more obvious and easily measured change in climate, but atmospheric moisture, precipitation, and atmospheric circulation also change as the whole system is affected. Increase in the temperature lead to increase in the moisture holding capacity of the atmospheric at the rate of about 7%. Together, those effects alter the hydrological cycle, especially characteristics of precipitation. So that the key parameter to be measured by space-based observation system, and I expect the GPM project will be contribute to this program. The other things is to characteristics the human organized air pollution properties. The mitigate climate change effectively at the space-based system point of view. The reliable observation production is very important for this data archive and their integration by international cooperation, and also cross comparison of sensors and joint calibration and validation like G6 activities is very important, I think. Thank you.
Thank you very much. Now the next speaker is Dr. Gassem Asrar, the Director of the World Climate Research Program.
Thank you very much, Jean-Louis. Good morning, ladies and gentlemen. It's a great pleasure for me to be here with you today in a new capacity. I'm currently based in Geneva on loan from U.S. government to the UN system. And the purpose of my function is to see how best we can make progress towards understanding but more importantly, using the knowledge that we have about the climate variability and change to inform some decisions, not only on the subject of mitigation of the causes of climate change, but also towards adaptation and, of course, managing the risks associated with climate variability and change. Let me just frame the question a bit differently, that based on the capabilities that the space agencies have put in place over the past 20 years, we can now make some statements about what is happening to the Earth's climate system. We know that based on the current level of greenhouse gases in the atmosphere and, of course, the introduction of fossil fuels for the rest of until the middle of this century, we're committed to about 2 to 2.5 degrees warming of the Earth's climate. And if we stay on the current trajectory of introducing further greenhouse gases, especially CO2, into the atmosphere, That figure probably is going to be close to 3 to 3.5 degrees by the end of this century. So the challenges that we see in front of ourselves as far as climate change is concerned is to see if we can come to an agreement at the global level to mitigate to as much as possible the introduction of greenhouse gases to reduce or to curb this enhanced warming on one hand, which really is the subject of mitigation. The focus of the discussions that will come up in December in Copenhagen is specifically on this topic. Can we get the commitment of the nations around the world to reduce the enhancement of the greenhouse gases for the rest of the century? Then at the same time, knowing that we are committed to about 2.5 degrees warming, what measures can we take to provide some knowledge about the impact of climate variability and change in different regions of the world, and what measures those nations, those regions can take to adapt to the change, to mitigate the impact, adverse impact of the change on their sectors of interest, whether being agriculture, water resources, transportation, tourism, to just name a few. And what is challenging with respect to the adaptation is that the problems are going to be regionally specific. Therefore, the knowledge of climate variability change has to be at the regional level, has to be at a much higher resolution. And therefore, our emphasis and our focus has to shift from global to regional to local. And that requires greater fidelity, resolution in the measurements. And it requires improvement of the models. Most of the climate models, the climate projections, prediction models that we have today were developed to look at the problem at the global level, look at the projections on centennial or longer time scales. But most adaptation-related decisions are most probably from interannual to seasonal, and at most to the decadal time scales. And most of the observations and models that we have are not sufficiently really developed or equipped to give us that type of projections and prediction for the regional decision making and for adaptation related activities. So as you can see, the emphasis and the challenge is somewhat shifting from the sort of the past 20, 30 years. Having said that, we really are quite fortunate to have established such a solid foundation for observing, understanding, and predicting and projecting the climate variability and change. And as we develop those capabilities to get greater understanding of the climate variability and change at the global level, we naturally had to tackle the problems at the regional level to scale up to the global level. So we have some networks and capabilities at the regional level that we can utilize to downscale our understanding from global level to regional level. Nevertheless, the challenge of providing the information in a way that is useful to the regional decision makers is going to be quite challenging. And so this is an area where we believe the space agencies can help, not only with providing the continuity observations, but also building capabilities that allows us to observe these changes both spatially and temporally, commensurate with the problems that the regions will have. Let's take a few examples of the things that really we need to do a better job. One of the key areas that we underestimated over the past couple of decades is the role of cryosphere, the polar regions in the climate variability and change. And we thought we had a longer period of time because we thought that the cryosphere is by far the slowest changing part of the climate system. Lo and behold, you've seen the observations from space of the sea ice concentration changes the gradient melting of the two poles, the large ice sheets, both in north and south pole, and the impact of those, plus the warming of the ocean, manifests itself in sea level variability and change. And the impact of sea level variability and change regionally is going to be significantly different. Therefore, we have to be able to provide that knowledge at the regional level to the coastal communities, to the nations that are impacted by those changes. So one of the highest priority areas is, of course, the continuity of the observations of the pole regions, both from space as well as in situ, to understand how these large ice sheets are changing very rapidly. Another major area that we really need to continue to focus on is the subject of carbon. The storage of the carbon both in the oceans as well as in the terrestrial ecosystem. The atmospheric component of the carbon cycle is reasonably well constrained, and we have a good handle on that. But our understanding of the oceanic and terrestrial components still needs greater improvement. The subject of greenhouse gases was introduced. As much as we have been successful in observing the atmosphere and the constant buildup of these gases in the atmosphere, most of the capabilities that are upcoming over the next decades do not have, for example, the limb sounding that allow us to get the concentration of these greenhouse gases as a function of the atmospheric height. That clearly is an area that we have to focus on. When we bring these observations together with models, as I said, the improvement of the model capabilities to be able to give us regional assessment of changes, their impact on different sectors that are of interest to different regions of the globe is of great interest. And this is an area that we are heavily focusing on, regionalization of these climate projections and predictions. The decadal predictions and predictability of the climate is something that is new to most of us, and we're really tackling that, for which we need to have a better understanding of the deep ocean circulation and what is happening to the greater depths in the oceans as far as the storage of the heat, carbon, and other nutrients are concerned, is a major area of emphasis for the coming decades. Now, when you put all of this together, we don't have a network currently in place to deliver this knowledge of climate variability and change to the decision makers at the regional level. At the end of August, early September, there was the third World Climate Conference in Geneva, more than 2,000 participants with 100 plus countries and 90 organizations came together, agreed to establish for the first time a framework for delivery of the climate knowledge to serve the nations around the world. And it's this concept is referred to Global Framework for Climate Services. And what it is and what are the roles and responsibilities of different organizations around the world, including the Space Agency, is something to be defined for the next 12 to 18 months. But this framework is needed to connect the knowledge that we generate with the users of those knowledge for decision making, and it's specifically, as I said, to help us manage the risk associated with climate variability and change at the regional level. The key essential element that can put all these pieces together is really having the expertise, having the technical talent and know-how at the regional level to take up the best available information, to interpret that information in the context of the needs of those regions. And unfortunately, in most part of the world, we do not have such a network. Therefore, education and capacity building at the regional level, especially in the developing and least developed part of the world, is really key to our ability to demonstrate the benefits of the observing networks, the modeling capabilities for decision makings across the globe. So when we put these combination of continuity of observations together with new observations to capture the unknown parts of the climate system, building the regional modeling capability and developing regional assessments and developing regional capacity for interpretation, delivery of the information are the key issues that are facing the global community. The World Meteorological Organization that has been in place for the past century has demonstrated that such a network, such a capability can be put in place through cooperation of 188, 190 countries. Today, WMO is delivering weather services, the impact of the information about high impact weather to the nations, to the regions around the globe. So WMO is taking the lead, coordinating the development of this global framework for climate services with partnership of the rest of the UN system and a whole host of other entities around the globe. I'll see a great opportunity for the space programs to contribute to this framework for climate services, and we look forward very much to continue to work with you to deliver the best available information about the Earth's planetary system to make a difference in life of those who are affected by the climate variability and change. Thank you very much.
Okay, I wish to thank the speakers, and now I would like to welcome Ambassador Ciro Arevalo Yepes, who is the chairman of UN COPUOS, and who will give us his view and his recollection of the outcomes and recommendations from the UN IAF workshop of last week.
Thank you.
Thank you very much.
Good morning, everyone. Thank you, Jean-Louis. It is an honor and a privilege for me to report on the workshop that took place here in Daejeon, which subject was the integrated space technologies and space-based information for analysis and prediction of climate change. I am doing that on my capacity of co-sponsor of that particular event. I am the chairman of the Committee on the Peaceful Uses of Outer Space, which is composed by 69 countries. And I am very glad to report that this year, during the June meeting, we have included the climate change issue as one of the top priorities in the agenda of the committee. Of course, it's relatively new since 1999, when the third worldwide conference, Unispace 3, took place. This particular subject was one of the most important ones. This workshop was, in my opinion, a success. It was a combination of very strong contributions. It was co-sponsor not only by the United Nations, of course, but also by the IEF, ESA, and of course CARI. The following issues were considered in the end of the round table, which has in fact 3 different topics in the basic agenda. And those issues were climate change, data generation and distribution. That was the first one. The second, capacity building in access to and use of climate change data. Third, awareness development among policy and decision makers. And then finally, international and regional cooperation. The findings of the workshop were: climate change is a global problem that needs, of course, global solutions, but with local effects. Comprehensive satellite data on climate change is currently being generated. That was accepted by everyone. But scientists have noted that data coverage, resolution, accuracy is not sufficient to address all climate change issues. So in the end, we have a lot of things to do in the near future. Third, data to be more readily available is in a standard format and a low price, so that the maximum benefit from such data could be derived in all parts of the world. One of the strong messages of this particular workshop is the question of data, the price of data, and we will see that in the conclusions. Development of satellite data into the necessary derived climate change information system needs to be strengthened. Fifth, enhanced international coordination is required for better presentation of climate change information for the policy and decision-making process. That is an important aspect. One important finding is, one thing is the data, and other thing is the information derived for that. Then, in the findings, regional centers needs to be a source of public information to inform non-specialists at the policy and decision-making levels in government and industry. Now, I will share with you the conclusions. First, satellite-derived climate data standards and systems that are globally available, free or at low price. I want to underline this particular aspect. Free or at low price should be developed and adopted. Constellations of microsatellites could have a good potential here. Second, regional groups or centers, and in the end platforms, with globally shared access to satellite data for developing and sharing regional and global climate change information could be identified and established within existing institutions. Third, capacity development capabilities to these centers with international access are needed. Fifth, commercial, university, government, and local community partnerships for such centers should be considered. Climate change information derived from satellites must be presented in a language that should be understood by policy and decision-making levels of government and industry. And then finally, one-stop international coordination for climate change information is needed in order to respond to the needs defined at the regional level. It's a kind of global governance for climate change. This should provide a standard format data and support decision-making process in the region. So in the end, it's a kind of process, simultaneous process, global governance as a top-down approach and a bottom-up approach by the regional capabilities development. So this is the conclusions of this workshop. I think that we have a lot of things to do. It's a very good basis and a contribution of this particular forum to the Copenhagen, the conference, which is going to be held in December this year, and is going to probably be one of the historical conferences. So we are very satisfied to have this contribution with us, and I would like to reiterate my appreciation to all experts who participate in this particular forum. Thank you.
Okay, let me thank again all the speakers. We have been extremely fair with the timetable. And so we have a few minutes for questions if you have any. If you have questions, please use the microphone on the side. Okay, so apparently we have been so convincing that there is no question. So let me thank you again for being there. Oh, sorry.
Yes, thank you for your presentation, Mr. Arevalo. I would have a question regarding to the possibilities of further ties between COP-WAS or the United Nations and IAF. Do you think there might be some possibility of financial flows from, public support for public interest?
This question is for you. Press the button.
Yes, thank you for your question. In fact, one of the very important aspects that we are developing is a common strategy between COP-WAS and IAF. You should remember that we have, if I may say so, different constituencies. In one side you have COP-WAS, which is composed by member states, and in the other side you have IAF, which is composed by agencies, space agencies, of course, private sector, industries, academia, a range of different actors that for member states are very important to have to establish those particular links. So we have developed in the last 2 years a very interesting type of cooperation based on common interest. We have compared our own objectives, and there are a lot of similitudes. We are aligned with the same objectives: peaceful uses of outer space, international cooperation. So in that particular respect, we have a kind of mandate to develop this cooperation. One of them is in fact this particular workshop. This particular workshop is in fact the demonstration that we can work together is financed by both institutions, by COP-WAS and by the IAF, and I think that we can work in that particular direction in the future. But more than that aspect is the content, the substance of our cooperation in terms of the important items we have to tackle in the future. IAF is participating very strongly, designing themes within COP-WAS subcommittees, particularly the scientific and technical subcommittee, when they brought new items. Last year was the industry. So it's a very strong and good combinations. We have a very strong synergy, and I think that you raise an important question. In the future we can strengthen our cooperation. I am very optimistic on that regard.
Any other question? No. I would just like to make a short comment about the question of the cost of the data. You have insisted, Ambassador Arevalo, on the issue of providing data at the lowest possible cost or for free. In fact, atmospheric observations and ocean observation as essentially available for free from all space agencies and from the meteorological community in general. What the issue is important is about the land imagery, which frequently is obtained from commercial satellites, and this is where there was an issue so far. One important information and interesting information in the fact that for the Sentinels program of the European Space Agency, which I've mentioned in my earlier presentation, the European Space Agency is going to propose a data policy for these systems, which will include coarse resolution imagery of the Earth, which will be completely open and free. Well, if there is no more comment, then I would like to thank you again and close this session. And I wish you would like join me for a round of applause for all the speakers. Thank you.